All right, so today we are going to continue on with congruent figures, but we're going to get much more specific. Rather than all figures like hexagons and quadrilaterals and things like that, we're only going to focus on triangles. And again, last time with congruent figures, we learned, and we actually did a proof like this, it was the last proof in the notes, that if we wanted to prove that two triangles were congruent, we needed to show that all three corresponding sides were congruent and all three corresponding sets of angles were congruent. And that was true at the time, but happily, we actually have a postulate that talks about congruent triangles, and it's called side-side-side postulate. Now, the side-side-side postulate, and by the way, we will just refer to that as SSS. Please say side-side-side, but we only need to write SSS. So the side-side-side postulate says that if three sides of one triangle are congruent to three sides of a second triangle, so corresponding sides are congruent, then the two triangles are in fact congruent. And this can be shown if you take three sticks or three different size pencils or pens, and if you put them together as a triangle and then mix them up and put them together again, I mean, you're always going to be making the exact same triangle. So this is in fact true, and we can then work this in a proof. So when we're proving triangles using side-side-side, again, the only thing we need to know are three pieces of information, and side-side-side implies we only need to know that three corresponding sides are congruent. The types of proof we're going to do today are not two-column. You could do this as a two-column proof, but when we're proving that triangles are congruent, my preferred method is a flow proof, and we had discussed this earlier, but now I want to show you in more detail how to write a flow proof. First thing is first. When you are proving that two triangles are congruent, anytime you're proving two triangles are congruent in this class, you are going to have this structure in your flow proof. All right, give me a moment to draw the structure here. And remember, flow proofs have the boxes where your statements go, and then underneath the boxes are the reason for that statement. And then you also need to draw arrows showing the flow of the logic, which things tell you what other things. And so this is our basic structure that we are always going to have when we are trying to show that a triangle is congruent to another triangle. And so what this is saying is that we have three pieces of information that together tell us those two triangles are congruent. Now, in this scenario, we're going to have three sides. It'll be side, side, side. So we need to go through and actually state our statements here. What do we have? Well, let's look at the givens. We know that line segment LM is congruent to line segment NP. That was given to us. We know that line segment LP is congruent to line segment NM. Again, that was given to us. And we're looking for one more piece. And by the way, we already know what goes in that last box over there on the right because it's what we're trying to prove. Triangle LMN is congruent to triangle NPL. That should be a easy point on a test or a quiz. Okay, so we need to fill in the blanks here. We have a statement and a reason that we need, and then we also need the reason for why the triangles are congruent. I bet you can guess what it's going to be, though. They did tell us to use side, side, side. So let's see what other side we need. So looking at one of our triangles, let's just look at this one up here. We already know that this side is congruent to another side in the other triangle. We know that this side is congruent to another side in the other triangle. So the only side of this triangle that isn't already congruent to something else is this side here, line segment LN. Well, look at that other triangle. In that other triangle, line segment LN is again the only side we don't know anything about. And so we can say that line segment LN is actually congruent to itself because it's the exact same line segment. Both of those triangles actually share that side as one of their sides. So we know that line segment LN is congruent to line segment LN by the reflexive property. And if you don't remember the reflexive property, that is in your section 2.5 notes. 2.5 is actually in Unit 1 and Unit 2. It's that one section we actually had in both, so you can find it in either unit. All right, and we're done. That's it. We know that those two triangles are then congruent because of side, side, side. Let's try another one. All right, again, I am trying to show that two triangles are congruent, so I'm going to set up that basic structure. We're always going to have that same basic structure when we're trying to prove that triangles are congruent. Okay, and I know that I'm trying to prove that triangle BCD is congruent to triangle BFD. I'm given that line segment BC is congruent to line segment BF. I'm given that line segment CD is congruent to line segment FD. All right, well again, looking at these triangles, if I look at this triangle on the top and I look at its counterpart on the bottom, I see that both of those triangles share this line segment BD. And so that must be the missing side. Oops, let's not do that in red. Line segment BD is congruent to line segment BD. Again, that's the reflexive property. And so now that I know that three sides of the top triangle, triangle BCD, are congruent to the three sides of the bottom triangle, triangle BFD, I then know that those two triangles are congruent by side, side, side. All right, well, we actually have another postulate that we can do here that we're given, and that is Sideangleside. And so again, rather than having to use all 6 pieces of information, meaning 3 sets of congruent angles and 3 sets of congruent sides, to show that two triangles are congruent, I can actually only need to know 2 sides and then the angle that's between them. There's a reason why this is called Sideangleside, is because you literally know 2 sides and then the angle between them. And so we say Sideangleside. You can just write SAS. So a couple of things. We need to know what is meant by the included angle. The included angle means that if I'm dealing with this line segment, BA, and this line segment, AC, then A is the included angle. Notice that A shows up in both of those names. It's the angle that is between those 2 sides. Okay, sometimes we're going to deal with, in fact, tomorrow, either tomorrow or Wednesday, we're going to be dealing with included sides. It can be dealing with sides as well. And so over here, I have, if I talk about angle B and I talk about angle C, then line segment BC is the included side. Again, it's the side between these two angles, B and C. So the included side is talking about the side between two angles. The included angle is talking about the angle that is between two sides. So side angle side deals with two sides and the angle in between them, the included angle. And so if we have that information, then we know that our two triangles are congruent. So taking a look at our example here, they want us to figure out what other information do we need to know in order to prove that triangle DEF is congruent to triangle FGD by side angle side. All right, well, let's see here. I'm just going to organize this as a proof, even though they didn't technically ask us to write a proof. So I'm trying to prove triangles are congruent, and so I'm using my standard structure here. I'm trying to say that triangle DEF is congruent to triangle FGD, and I'm trying to prove that by side angle side. And so I'm even going to write off to here, side angle side. So what do we have so far? Well, we are given that line segment EF is congruent to line segment DG. That's shown in the diagram. It's a set of sides. And actually, hopefully you notice here now that these two triangles share this side. They share that side, and so we know that line segment DF is congruent to line segment DF. That's by the reflexive property. Now, you don't have to organize your proof this way, meaning you don't have to have a side in the first one and a side in the second one and then looking for an angle. The only reason I did that is to help us focus on, well, what extra piece of information do we actually need? This is not something we need. It's something we can already figure out from the diagram. Well, something that we can't figure out from the diagram are a set of congruent angles. And so we've got to decide which angles do we need. Well, in order for side angle side to happen, we need to have two sides and the angle between them. So let's take a look here. Line segment EF and line segment DF both have F as one of their endpoints. And so angle F is the included angle. The problem is we can't call it angle F. Which angle F are we talking about? We're talking about this angle F. And so I am going to call that angle EFD. Angle EFD is my first angle I need. Angle EFD needs to be congruent to what other angle? Well, you might already see it here. We have line segment FD and line segment GD. So again, D is then that included angle. And that's the one we would need to have congruent. And so naming that one, I'll do it here in gold. We start out with FD. G. Remember, the vertex always has to be in the middle of the name. So angle FDG. And so that's what I need. That's the missing piece of information that I have to have. then we can prove the triangles are congruent by side, angle, side. All right, a couple of quick examples here on the bottom. We just want to know, are we able to show that these two triangles are congruent by side, angle, side, or is there not enough information, or can they be shown or congruent by side, side, side? So I'm going to pause just for a moment, or actually I want you to pause for a moment and write down an answer for each of these and then come back and see if you got them right. All right, well, hopefully you have paused and wrote down your answers for each of these. If you have not, please do so now. But A, we actually have a set of sides that are congruent, another set of sides that are congruent, and the angle between them are congruent. So these can be shown are congruent by side, angle, side. For B, if you look at the first triangle, it looks nice. We got a pair of sides here, congruent to this side there. We got another side here, congruent to this side there. We have an angle in between them here, but oops, it's not the angle there. The angle's in the wrong spot. And so we have not enough information. Okay, because the information we have doesn't actually help us. Looking at part C, we have the three sides of this triangle are congruent to three sides of that triangle, and so sure, they're congruent by side, side, side. And for part D, if you just look at it, you see that there are three sets of sides that are congruent. So you're going to say, oh yeah, side, side, side. But if you look a little closer, you might notice that we actually have vertical angles right here. And so because we have those vertical angles, this side is congruent to this side, and this side is congruent to this side. And so right there, we actually have side, angle, side congruent as well. And so we could actually use either of those to prove those two triangles are congruent.